Welcome to the universe of the mind. You'll be amazed at the things that you might find in a galaxy far, far away. The secrets of our world will be exposed today.
2. Have you ever wondered why, despite all the memes and online debates, scientists are so certain the Earth is round? It's not a conspiracy. It's because every single piece of evidence from physics, astronomy, navigation, and even simple observation points to one undeniable fact. We live on a rotating sphere. Let's break down the most powerful proofs, one by one, and see why the flat Earth idea just doesn't hold up. First, and most obviously, we have pictures. And not just from NASA. Hundreds, if not thousands, of satellites are orbiting our planet right now. They're operated by space agencies from Europe, Japan, Russia, China, and India, as well as private companies like SpaceX and countless telecommunication firms. All of them, without exception, show a beautiful curved Earth. To believe in a flat Earth, you'd have to accept that every single one of these organizations is from different countries with different political and economic interests, has been collaborating on the same elaborate hoax for over 60 years. Does that sound plausible? Or is it more likely that the Earth just looks round because it is round? The simplest answer is usually the correct one. Next, let's talk about something we experience every second of every day: gravity. Gravity pulls everything toward the center of mass. Oh, on a spherical Earth, that center is the core of the planet. This is why Tao is always toward the ground, no matter where you are. It's why people in Australia do yunt, fall off into space, and why an apple dropped in Argentina falls the same way it does in Canada. Gravity pulls everything perpendicularly toward the surface. Now, imagine a flat disk. Gravity would still pull toward the center of mass, which would be in the middle of the disk. This would mean that if you were standing at the center, gravity would pull you straight down. But if you moved toward the edge, gravity would start pulling you sideways, back toward the center. Trees would grow at an angle, rain would fall diagonally, and walking would feel like climbing a hill, getting steeper the farther you went. We see none of this. The force of gravity is consistent all over the world, which is only possible on a sphere. Here's an experiment you can see for yourself. Go to a beach or any large body of water and watch a ship sail away. You'll notice something fascinating. It doesn't just get smaller and smaller until it vanishes. Instead, the hull, the bottom part of the ship, disappears first. Then the deck, and finally the mast or the smokestack is the last thing you see before it's gone completely. This phenomenon is caused by the curvature of the Earth. The ship is literally going over the horizon, a physical curve in the planet's surface. If the Earth were flat, the entire ship would simply shrink until it was too small to see, but it would remain whole the entire time. The bottom wouldn't vanish before the top. This simple observation, known for thousands of years, is one of the most elegant proofs of a curved Earth. What about time zones? Why is it daytime in New York while it's the middle of the night in Tokyo? This is easily explained by a rotating globe. The sun shines on one half of the Earth at a time, creating day. The other half is in shadow, experiencing night. As the Earth spins, different parts of the planet move in and out of the sunlight. The flat Earth model tries to explain this with a small, local spotlight sun that circles above a flat disk. But this model has huge problems. First, it can't explain sunsets as spotlight. Moving away would just get smaller and dimmer. It wouldn't sink below a horizon. Second, it fails to create the sharp day-night divisions we see. A spotlight would create a soft, diffused twilight over most of the night area. And finally, it can't account for the seasons or the 24-hour. Sunlight experienced in the Arctic and Antarctic circles without completely breaking the laws of physics and geometry. Let's look at how we travel. Modern aeroplanes fly on what are called great circle routes. This is the shortest path between 2 points on a sphere. If you look at a flat map, these routes can seem bizarre. A flight from Santiago, Chile, to Sydney, Australia, for instance, might appear to curve way down toward Antarctica. It looks like a huge detour. But when you trace that same path on a globe, you see it's nearly a straight line. Airlines are businesses obsessed with efficiency. They want to use the least amount of fuel possible, which means flying the shortest distance. They use spherical geometry every single day because it works. It accurately predicts flight times and fuel consumption. Flat Earth maps cannot do this. Distances and flight paths on those maps are wildly inconsistent with reality. The fact that our global transportation network relies entirely on the model of a spherical Earth is powerful, practical proof. Even better, you don't have to take anyone's word for it. You can measure the curvature yourself. Over 2,000 years ago, the Greek scholar Eratosthenes did just that. He noticed that on the summer solstice, the sun was directly overhead in one city, but cast a shadow in another city to the north. By measuring the angle of that shadow and knowing the distance between the cities, he calculated the circumference of the Earth with surprising accuracy. Today, you can replicate this with a friend in a different city, 2 sticks, and some basic maths. Or, for a more high-tech approach, people have sent weather balloons with cameras up to high altitudes. Tens of thousands of hobbyists have done this. And what do they see? At altitudes of 20 to 30 kilometers, the curve of the horizon becomes clearly, unmistakably visible. No conspiracy, no CGI, just a GoPro and a balloon showing reality. Finally, we have a lunar eclipse. Happens when the Earth passes directly between the Sun and the Moon, casting its shadow on the lunar surface. Every time this happens, the shadow we see creeping across the Moon is round. A perfect circular arc. Think about it. The Earth is constantly rotating. No matter what orientation the Earth is in when it casts its shadow, that shadow is always a circle. There is only one geometric shape that casts a perfectly circular shadow from any angle: a sphere. If the Earth were a flat disk, it would only cast a circular shadow if the eclipse happened at a very specific time and angle. At any other angle, it would cast a shadow shaped like a thin line or an ellipse. But we have observed hundreds of lunar eclipses, and the shadow is always round. So when we put it all together, the photos from space, the physics of gravity, shapes disappearing over the horizon, time zones, airline routes, direct measurements, and the shape of our own shadow on the Moon, the conclusion is overwhelming. The Earth is a sphere. It's not a matter of belief or opinion. It's a conclusion based on mountains of verifiable evidence from every field of science and from observations anyone can make. The world is a fascinating, complex, and beautiful place. And understanding its true shape is the first step to exploring it further. Thanks for watching. And don't forget to keep asking questions and seeking out the evidence for yourself. Subscribe for more.
Welcome to the universe of the mind. You'll be amazed of the things that you might find in a galaxy far, far away. The secrets of our world will be exposed today. All is never what it seems. Is a world created by our dreams? Are we living in a simulation? Is the moon alien space station? Quantum is quantum does. Nobody knew just what it was. To this day we still don't know, but we won't stop exploring, no. Welcome to the universe of the mind. To the universe of the mind. You'll be amazed of the things that you might find in a galaxy far, far away. The secrets of our world will be exposed today. All is never what it seems. Is a world created by our dreams? Are we living in a simulation? Is the moon an alien and space station? Quantum buzz, nobody knew just what it was. To this day we still don't know, but we won't stop exploring though. Welcome to the universe of the mind.
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 Mind. To the universe of the mind, you'll be amazed of the things that you might find.